Welcome to TIPS Training and Certification Online Training Program. Now we will study the control charts for variable, that is X bar R chart and IMR chart under Six Sigma Green Belt training. Control charts. What are the control charts? Control chart is a trend chart which monitors whether the process is in control or not. Walter Shewart invented the control chart. It gives advance warning about the drift from the normal behavior. To draw the control chart for a process, we need to know the average and standard deviation obtained from the process. Control charts are of two types, that is variable chart and attribute chart. Variable means we can measure the data, whereas attribute we can't measure the data but we only count the data. Under variable chart there are X bar R chart, IMR chart and X bar S chart. What is variable data? The data that is continuous in nature and can be measured. For example, length, pressure, etc. What is attribute data? The data which is discrete in nature and can only be counted. For example, a pressure is successful or not. Now we will study the X bar R chart under variable chart. When to use this chart? When studying the behavior of single measurable characteristics produced in relatively high volume. For example, if we are producing the pen, then the dimension of that refill or dimension of that pen can be considered for the X bar R chart as a characteristics. How we can carry out this X bar R chart analysis? By plotting the sample averages, that is X bar and R, on the separate chart. This allows for independent monitoring of the process for average and variation about the average. The conditions required are constant sample size, one characteristics per chart, that is dia of that particular pen, should have no less than 20 samples before calculating the control limits. Steps to establish X bar R chart are: select the parameter, select the samples, decide the rational group. For example, we are carrying out the analysis for 10 days. Per day 5 samples, then subgroup will be 5, whereas sample will be 10 days multiplied by 5, that is 50 samples. Design the data sheet for recording the observations. Record the observations. Compute X bar and R for each subgroup. Compute X double bar and R bar. Calculate the upper control limit and lower control limit using the respective formula. Plot the X bar R control chart. Analyze the graph for different patterns and out of control limits and check the process which is within control or not. Based on the analysis, take the corrective actions. These are the formulas given for calculating the upper control limit and lower control limit for X bar and R chart. These are the certain factors which are required during the calculations in the particular formulas. A2, D3, D4, D2. All these are the standard values for calculations. Example. In a software company, Mr. Harish, who is software engineer, wants to know the development schedule for each project. He analyzes this data for the different projects. The data is given in next sheet. This is the data provided for the particular projects. for 16 weeks each Monday to Friday. Monday to Friday is the subgroup, whereas week 1 to 16 multiply by 5, that is Monday to Friday, is equal to your sample size. Now, how to calculate the things one by one we will see. Here 50.5, 43.5, 45.5, 39.8 and 42.9. All these values are added horizontally divided by 5, that is 5 subgroups are there. So average is 44.44. Whereas here range is equal to 50.5 minus 39.8, that is 10.7. Similarly, calculate the average and range values horizontally for 16 weeks. After that, in a average column, calculate the average of average column, that is 44.44 plus 42.24 plus so on up to 45.60 divided by 16, that is equal to 45.03, where as for our range 10.7 plus 5.6 plus up to 8.7 divided by 16 is equal to 7.59. Here x double bar is 45.03 and r bar is 7.59. The graph related to x bar and r is plotted. Now from this graph we can see that all the points are lying within the control limits of x bar chart as well as r chart. This means our process is under control. No action is required to correct the things. Now we will see the individual Rx moving range chart. Where we can use it, we will see. When the sample or subgroup size is 1, or when the samples have very small short-term variation, in these situations we are using IMR or IXMR chart. In situation where opportunities to get the data are limited, such as low production volume or testing, even that situation we are using IMR chart. Conditions required are sample size of 1, assumes normal distribution. How we are going to plot? By plotting each individual measurement of x and moving range between the successive measurements. This is the example of IMR chart. Here in individual value, all the points, that is values, are lying within control limits, whereas in moving range, even though the all points are lying within control limits, some points are touching to lower control limit. What it means? These are certain alarming points. We have to analyze for the further. How to calculate the control limits? These are the formulas given for IMR calculation of upper control limit and lower control limit. This is one of the example given for the calculation of IMR chart. Here the data are weekly sample taken from the process. First moving range plot point in the following table is the difference between 4.25 and 4.78, which is 0.53. Next difference is 4.78 and 3.95 is 0.83 and so on. This is the table provided with Ix values, that is 4.25, 4.78 up to 4.35 for 10 samples, whereas Moving range is calculated as discussed in previous sheet. This is the IMR control chart is plotted for the given data. For X, that is individual X, all the points are lying within control limits, but in moving range, one point is touching to upper control limit, which is the alarming point. Similarly, X bar S chart is used using the same formula which is given in X bar S chart. Only the difference between X bar S chart and X bar R chart is that X bar R chart there are samples below 10 or 20, whereas in X bar S chart the samples are more than 20. Thank you.